Chapter 3.5, Solving Addition Equations. So the vocabulary for today is inverse operations. Inverse operations are operations that simply undo each other. For example, addition and subtraction. 3 plus 2 equals 1. 1 plus 2 equals 3. They undo each other. Multiplication and division are also inverse operations. Okay? You can also think of inverse operations as 3 minus 3 equals 0, or negative 3 plus 3 equals 0. Take a moment to write down both the properties and the key concepts. The subtraction property of equality. If you subtract the same value from each side of an equation, the two sides remain equal. Equations need to remain balanced. And I like to remember that by thinking of a little scale. Okay, you guys have seen scales like this in science. Whatever I put in one side, I have to make sure I put in the other side in order for them to remain balanced. So let's take a look at example 1. In chapter 3.4, you are using mental math or guess and check in order to solve equations. Today we're actually going to go through the steps that you need to show when solving an equation. So I'm going to show you two different methods today. The first is the way that the book shows. So here I have a problem, x plus 4 equals 38. You're going to rewrite the problem because you must always write the original problem in your assignments to show your work. So I need to figure out what x equals. Well, if I have x something and I add 4 to it, I have 4 more than x. So if I want to get x by itself, I have to take 4 away from x. So step 1 is to subtract 4 from both sides. Just going to do this way. So I'm going to rewrite the problem x plus 4, and then I'm going to subtract 4 equals 38. Subtraction property of equality. If I subtract it from one side, I have to subtract it from the other. So x plus 4 minus 4 equals 38 minus 4. So that leaves x all by itself. X equals 38 minus 4 is 34. So method 1 is showing your subtraction sideways on the same line. Method 2 is the way that you will see me do it most commonly in class. However, you can use either method. So method 2, I again start with my original problem. X plus 4 equals 38. I'm still going to subtract 4 from both sides, but instead of writing it horizontally like I did here in method 1, I'm going to write it vertically underneath. One reason I like to do this is because then I can line up my addition or my subtraction right here, and it's really easy to show my work. So I've subtracted 4 from both sides, and then x equals 34. Either way you do it is fine with me, but you must show your steps. Okay? If you can do 38 minus 4 mentally, which you should be able to do, that's fine. Do it mentally. You don't need to show your computation, but you need to show your steps that you're subtracting 4 from both sides and then what x actually equals. Okay, so let's take a look at example number 2. When you solve problems using equations, sometimes drawing a diagram can help. Okay, we are going to look at part whole bar models today. This is a word problem. So example 2. When a kitten was brought home, it weighed 15 ounces. After 2 years, The kitten had grown into a cat weighing 120 ounces. How many ounces did the cat gain? So you need to write an equation. So we're going to start by answering two questions. What do I know and what do I need? So I know that the kitten weighed 15 ounces. I know that the cat weighed 120 ounces. What do I need to know? I need to know the number of ounces the cat gained. What you need to know, this is going to be your variable. So I'm going to call this X. So I'm going to start by drawing a bar model. This is a part-whole bar model. So I know that my cat started out as a kitten weighing 15 ounces. I know that my cat, when it was an adult, its whole weight was 120 ounces. So I need to know how much did it gain to reach that. Part whole. I know one part and I know the whole. So my equation is 15 plus X equals 120. Now notice that in my equation I am not including my units. I will go back and put my units in my final answer, but I'm not going to put them into my equation itself. So now that I have an equation, I need to solve it. So 15 plus X equals 120. Well, if I'm adding 15 to get to X, I need to do the opposite, or its inverse operation. So I'm going to subtract 15 from both sides, because whatever I do to one side of the equation, I have to do to the other. Therefore, I'm left with X on the left side of the equation equals 105. Now this is where I'm going to go put in my units. Because it's a word problem, you can also write a sentence. The cat gained 105 ounces. Okay? I'm going to tell you that the sentence is probably optional. The units in your X equals is not. Okay? So in this lesson, we have used the subtraction property of equality because we are subtracting from both sides in order to isolate X, in order to find out what X is. Okay, that's it for the lesson. Go ahead and do your QCs and your CYU, and we will go over this tomorrow.